So the output of this code clearly classifies first the engine, whether it's in the normal off or whether it is running. At the moment, the engine is not running. It is at resting state. So if you look at the classification, you find that it is 99% that the engine is off and 0.00 that it is running. So we know that the engine at the moment is off and the classification is done properly. Now, the anomaly prediction value is not applicable in this state. At the moment, what we are doing is we are classifying the engine state because we have added the classifier in the edge impulse. So now when we turn on the engine, you will see that the normal running engine percentage will be maximized and the normal off engine will be around 0. This indicates that the classifier is working properly. So now we're going to turn on the engine. Now as you can see that the normal running engine percentage is around 97% or between 90 and 97%. This means that the classifier has correctly indicated the state of the engine. So the anomaly prediction value will be useful for us when the vibration becomes outside the two clusters, i.e. when the values are outside the engine off cluster and when it's outside the engine running cluster. So now we're gonna mimic an abnormal vibration. And let's see how the anomaly prediction value increases and the orange LED turns on. The orange LED is going to turn off once the vibration goes back to its normal state. Remember that the code has an interval of capturing the data. It's not any time when you cause abnormal vibration the orange LED is going to turn. You have to wait when the start of the vibration capture occurs. So now we are capturing data. Okay, so this means we have something abnormal occurring at this stage, and now the LED, once it goes through the other cycle of capturing the data, is going to recognize that it is now back to normal state, and the LED is going to turn off.